Hello and welcome back to A&P with Emily. Today we're going to be going on to our final tissue, so our final of the four. We're going to go on to connective tissue. So connective tissue is the most abundant and arguably the most important tissues that we have in our body. It holds you together. It makes you up. So connective tissue is pretty much everywhere. I mean, it's not in abundance everywhere, but it is everywhere. So if you take your skin, you've got an abundance of connective tissue on your skin. Like we looked at epithelial tissue last lesson, we know that your skin is made up of your epithelial tissue and your connective tissue. But if you look in something like your brain, it's mainly nervous tissue, so you're not going to have a lot of connective tissue, but it is still there. Your connective tissue is everywhere. So we have got 4 different types of connective tissue. We've got proper. Now our proper is for things like our skin, so it's supporting our skin and our ligaments and things like that. And then the other 3 are cartilage, bone, and blood. Now you may be thinking, hold on a minute. They're not tissues, they're their own things. Bone, blood, cartilage, they've all got their own names. Cartilage, bone, and blood are just types of connective tissue. Okay, so if we've got all of that, how do we know what's connective tissue and what's other tissue? How are they defining factors? So if we didn't know that, how would we be able to tell what connective tissue was? So connective tissue essentially has to have 3 things. So all connective tissues to be branded as connective tissue have these 3 things. Now, the first one is they are all developed from something called mesenchyme. Fancy word. Now, all mesenchyme is a type of fluid embryonic tissue. But then, as the fetus develops, it grows into connective tissue, okay? So the first thing we need to know is it's developed from mesenchyme. The second thing we need to go is they have varying levels of vascularity. Okay, so if we took, for example, the skin, we know that that's definitely vascular, it's got lots of blood vessels in it. But if you took something like cartilage, most cartilage is avascular. Now we know what avascular means because if you watched the lesson before, we went into a little bit more of terminology and stuff. So we know that A is without, or A or an is without. So different levels of vascularity, and we went into that, and we know that that's essentially similar to blood flow. Okay, and the third one is they are all made, or mainly made, from non-living materials, okay? Okay, so they're the 3 really important things that we need to know about connective tissue and why it's connective tissue and it's not anything else. So what does our connective tissue actually do? You know, there's me bigging it all up and making it sound like it's really important, but I haven't actually told you what it does. So connective tissue, it does so much. So it binds and supports, it protects, it stores energy, it provides transportation for substances, it's responsible for movement, it's responsible for insulation. It does so much, and I feel like I'm starting to need a scroll or something just to read from all of those things. So it's super, super important. Say if we take something like fat. That's a cell, right? It's a cell in our body. A cell we wish we probably wouldn't have as much of, but we do. So fat is a type of proper connective tissue. And is responsible for insulation. energy storage, but also, which I think a lot of people forget, it's really structurally important as well. So it helps play a key part in holding all of your organs in place, okay? So fat, really important, as much as we don't like it. So it's proper connective tissue, provides insulation and energy storage, and also really important for structure. And then if we look at something like bones and cartilage, they connect, they support, and they protect your organs, and they make up your skeleton, okay? And the blood, we know what the blood does, so the blood transports the nutrients and the hormones and oxygen and all other materials all around your body. There's no other fluid that can do that. Very, very important, okay? So we've got those, we've got proper connective tissue, we've got cartilage, we've got bone, and we've got blood, all right? So I spoke earlier that all connective tissue is made up of mainly a non-living material. Now this non-living material is otherwise known as the extracellular matrix. Now this actually is more important than the cells that lie within that extracellular matrix. Okay? And that's because the support and the framework, even though it is slightly jelly-like, so this extracellular matrix is almost kind of jelly-like, but this is the support and this is the framework that gives us our connective tissue. Now this wonderful matrix is made up of two things. So first of all, we have ground substance, and we have fibres. Now, ground substance is a substance that fills in all of the gaps in between the cells. It protects them, it makes them flexible. Very, very useful. So ground substance protects our cells. And fills in the gaps. Fills in the spaces. Fills in the spaces between them, okay? So imagine you've got lots of cells and they're all kind of floating about, doing their own thing, just chilling, but the ground substance makes sure that that's all now tightly packed. Not necessarily tightly packed, but it's all filled in. You've got a much more substantial framework or groundwork. Substantial groundwork. Now the fibres themselves really provide the support and the structure to the goop that is the ground substance. Okay, so these provide support and structure. Okay, so we're going to take a little look at the fibres now. So we've got three main types of fibres within the ground substance, okay? So we've got collagen. Collagen is strong, it's tough, it's flexible, it's brilliant, and you obviously recognise that collagen is what some people inject into them to make them look younger. So collagen is strong, tough, but also flexible. Now elastic fibres kind of already speak for themselves, so they form a kind of stretchy framework, so it allows them to stretch and recoil as well. So framework, allow for stretch and recoil. And reticular fibres, which you might not have heard of, are a type of shorter, thinner collagen fibre. Okay, so it's shorter, thinner collagen fibre, and it forms like a net-like network, if that makes any sense. And it holds your organs in place and not necessarily cushions them, but it provides a safe net, like a safety net for them. cradles them like little babies. Okay, so we've got collagen fibres, elastic fibres and reticular fibres. Now we've spoken a lot about the extracellular matrix. I want to go into the cells, even though the extracellular matrix is more important overall than the cells. The cells obviously still are really important. So the cells exist in two phases. So you've got a blast phase and a site phase. So blast, although it sounds destructive, actually means to form. Okay, so if you have a blast cell like an osteoblast, now let's just break this down really quickly. So osteo we know will be bone from one of our last lessons, and blast we know now means forming. So it means it's going to be a forming bone cell, all right? And site, so an osteocyte, while it's in its next phase, so this is the forming of it, and an osteocyte needs to maintain that matrix. And sometimes, even if it's necessary for repair, an osteocyte will send the cell back into its blast phase if it needs to repair itself. So the blast cells create and secrete that ground substance and those fibres to create that all-important matrix. And the sites have to maintain it and can also deal with it regarding repair. So we've been through all of that, and all of this cool stuff that your connective tissue does is to make you up. They assemble you, so your bones, your cartilage, your blood, your tendons, everything makes physically you up. Thanks very much for watching. If you're new to this and this is your first time watching and you enjoyed it, give us a thumbs up and hit the subscribe button if you're interested. Everyone else, please again feel free to share this. Let's get this to as many A&P students as possible. From me and Kenny, bye.